So topic 16 is going to ask if you know the height of a launch and the velocity with which it will leave, how far away will, say, a cannonball in this example land? Now this is using the simulator they're going to do your homework assignments with. First thing that you know is that the height is 11.6 meters. So I'm going to go height equals 11.6 meters. We also know right over here that the speed coming out is 18 meters per second. Because the angle is a flat zero, it's neither being shot upward or downward, so it's completely velocity in the x coming out. In order to solve for velocity in the x, well, we know that this distance right here, x, well, this forward velocity is going to be constant the entire time. So I can solve for x equals velocity in the x times time, and that's my missing link. This is what I need to find. However, I do know however long it takes to fly forward is also how long it's falling downward. So that's going to be the first step. Step 1, time to fall. As if it weren't launched at all, as if it were just dropped. It's exactly the same, just like the bullet video we saw for Mythbusters. Step 2, use time to solve for the distance, horizontal, or x. Those are our two steps. The time to fall tells us how long it's being shot forward, which we can use to find our distance. Let's do part 1. Okay. Time to fall. I know if I'm looking at the downward motion, the initial velocity equals 0. That's downward, because it's shot forward but has no downward velocity. The ending velocity, I don't know. That's downward. We don't know how fast it's going when it hits the ground. Time, we also don't know. Acceleration is negative 9.8. And the height, or the change in y, equals negative 11.66 meters because it's falling downward. The formula that we can use to solve for time, this is the important one. We need a formula that will help us solve for time. So we have y equals starting position plus velocity initial times time plus 1/2 at squared. This is 0 plus starting downward velocity 0 times time 0 plus 1/2 negative 9.8 times t squared. This is 11.66 downward. Negative 11.66, that comes from the height, but it's falling down, equals 1/2 negative 9.8 times t squared. Negative 11.66 equals negative 4.9 times t squared. Now we divide by negative 4.9. 4.9. Where's my calculator? Oh no. Tools. Oops. 11.66 divided by 4.9. The negative signs cancel. So I know time is 2.37 seconds. Now we can do the last step. So this is our process. We didn't need the final velocity. We just need knowing that the starting downward is 0, acceleration is 9.8, and the height was enough to give us time using that formula. Last step. Use time to solve for displacement in the x direction. Velocity in the x equals 18. T equals 2.37. Displacement, we don't know. But because acceleration is constant, x equals velocity in the x times time. Or 18 times 2.37. I just realized I forgot one more step back here. Oh boy. That equals t squared. So the last step is to square root that number. So let's bring back my calculator. Square root 1.54. So I forgot there's one more step. We have to square that t, get rid of it, by square rooting our answer that we thought we had. So it was this number right here, 11.66 divided by 4.9 with 2.3. Then square that equals 1.54. Okay, glad I caught that. So no, 18 times 1.54. Bring this over here. 8 times 1.54 equals 27.72 meters. So let's go check our answer. I'm going to go over to this guy right here. Oops. And I'm going to set this, I'm going to set this distance to 27.72 or something close to it. That should be close enough. And then we'll press fire. Go, 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 go. Bam. A little bit short, but that was a little bit short also. Score. That's how we check our work. So your homework is to change the height of these, change the velocity here, and then check your work. You have to write out 3 problems and solve them. So I'm not checking your simulation. I'm checking your video, the actual problems that you write out in the work that you do.